This is going to be a what we call a construction, but it's also so the geometry is a geometric construction. We'll talk about what that means here in a little bit. But it's a practice right now in kind of listening skills and being able to pay attention to directions. Because if you don't pay attention to the directions and you kind of try to work ahead or you can't keep pace, you're going to develop something that is not what we want. Okay. Geometric constructions are very step orientated. If you skip a step, miss a step, add a step in the wrong spot, it's going to throw everything off. In your construction, your final result is not going to be completed. Okay. Now, what a construction is a long time ago when Euclid was alive, and he was creating or kind of constructing his geometry, the geometry that we're currently familiar with. He had the kind of personal issue of wanting to be able to perfectly maybe bisect an angle or perfectly bisect a segment. Okay, and you guys know this stuff from science, hopefully. But if I have, let's just say I give you a segment. I'm going to give you an image here. Let's say that's my segment. And I want to measure that segment. So I get my ruler out, and I put my ruler next to my segment. I don't know how to rotate this or spin it or whatever, so let's do this. So I put my ruler next to my segment, and we see here that, it goes up to 3. I think this has probably got, I don't want to count them, but it probably goes by 16ths. There's a quarter, it goes by 16ths on my ruler. So hopefully you know that I'm not going to be extremely, you guys talk about in science the word precise and accurate, right? Okay. I'm not going to get a good measurement of this thing because my tool is not all that precise. It only goes down to 1/16 of an inch, right? So if I measure this, it sits between 3 and 1, 2, 3, 4, 5, 6. Okay, so right there is. If I look right there, that's. There. That mark right there where it ends is 6/16, and the one right after it, I'm not sure what it's doing. The one right after it is 7/16, right? You guys understand how to read a ruler. But if my segment falls somewhere in between those, in between 6/17 and 7/17, am I going to be very accurate in finding the midpoint? No, because I'm not sure, because my tool is not all that precise. I'm only going to be accurate up to the nearest 16th of an inch, right? When I cut it in half. Okay? And that's what you guys talk about in science with 6 figs, right? Okay? Euclid had an issue with this. He said, I want to cut that segment directly in half, 100% in half, and not have to rely on an instrument that isn't very precise. Okay? Because I could put 100 markings in between 3 and 4, and I'm still going to be, at some point, not 100% accurate. Right? I'm not going to cut it exactly in half because I might be spoiling, my segment might end between 3 and 45 hundredths and 3 and 46 100ths. Okay? I'm going to be a lot more precise, but still not accurate on finding the midpoint, right? Does that kind of make sense to everybody? And no matter how many points you put in, how many markings you put in between 8 and 2 inches, you're going to get more and more precise the more and more markings you put in on your ruler, but you're never going to be 100% accurate. And that's kind of one of the things Euclid thought about and said, I don't like that idea. I want to be 100% accurate. I want to use an instrument that's 100% precise. And what he came up with is you should be able to do this for the most part with some of the things we talk about in geometry using a compass. Okay? Now I want to make sure we all understand what a compass is. I had some people the other day, or not the other day, last period, thinking a compass was like north, south, east, west, right? Okay? Geometric compass. Okay. That's a compass up there, right? What does that measure? What does it do for us?
Angles.
Oh.
I don't know.
The radius.
Okay. So this distance between that point right there and that point right there, the point of the needle and the point of my lead or marker or whatever I'm using, as a straight line, is the radius of a circle. That makes sense? If I do it this way, you see that you get that circle, right? Okay. So what a compass does for us, ultimately, is simply measures the distance of a segment without having to use a ruler. Does that make sense? Okay. I can put my compass up on a segment, no matter what segment it is, and I can transfer that distance anywhere I want to. Okay. Well, after that, there's a couple steps that we can go through. Once I get a distance on my compass, there's some steps we can go through to bisect that distance, to cut that distance in half, 100%. Okay. And we can do that with other things, like angles. If they don't want to bisect an angle, we can use a compass and straight lines, segments, to bisect an angle. All right. And those were some of the things that Euclid was interested in. That's one of the main problems that he kind of messed around with when he was developing this stuff. Okay, not developing, but kind of putting it all together. Okay, because he gets the name for being the father of geometry or whatever, but all these ideas are not his ideas, right? Okay, he took information from all types of people, all different areas. So, what we're going to do today is we're going to do a construction. We're going to bisect an angle. Okay, and it's going to be important that we pay attention to directions, but also at the same time kind of understand what's going on here. Okay, I'm going to give you a series of steps, and in the past, I've had people just try to focus on the steps. I don't want you to focus on the steps. I want you to focus on what those steps are doing for us, what they're creating for us. All right, so as we go through this, we're going to start highlighting things and think about what those two steps just did for our overall conclusion in regards to bisecting an angle. All right, so got to pay attention, got to listen to directions. This is our first construction that we're going to do. The end of course exam asks you periodically to maybe walk through a series of steps to construct something. They might say, hey, these are 3 or 4 steps that we've gone through. What are we constructing? Or they might say, here's the construction, the steps of constructing an angle bisector. Here are the steps of constructing a perpendicular bisector. Identify the step that we did incorrectly. Okay, so those are the types of questions you might see on an end-of-course exam. And we'll do a handful of constructions over the next couple weeks to kind of get practice at this. Okay. Right now, what I want you guys to do is to come up to GeoGebra. Actually, first thing, right-click on your page and go down to Axes. Click Axes. Get that out of there. And then right-click again and click Grid and get that out of there. So I just want a blank white screen, or some of you have pretty turquoise screens. All right, now click on your point tool, okay, and you're going to click 3 spots. Okay, now my suggestion to you as we do constructions in class, you're trying to mirror what I do, right? Okay, so when I say click 3 points, try to click them. I'm not saying you're going to find the exact same 3 points that I did, but kind of click them in the same fashion. Does that make sense? Okay. I then want to click on this 3rd box, which is your line tool, and you get portions of lines. I'm going to go down to array. Click on array. And I'm going to click on B, and then click on A. And it creates ray BA, right? Okay. I then want to do the same thing for B to C. Now, as we do this stuff, some of you are going to develop maybe a little bit more proficiency in this program than other people. You can always, I want to create B to C again. I want to create another array. So I can click on B and click on C again. But I can also just come over here and click on B and then click on C, and it will give me that ray as well. Okay. But make sure, because rays, the way we name array is important, right? So if I want to click C and then B, it would give me the wrong ray. Does that make sense, everybody? Okay, so just kind of show you that. If I were going C to B, it gives me that ray, which is not what we want. We want this angle here, but we don't want the ray going off that other direction. So we go B and then C. All right, so doable? Now we want to go over, we don't want to delete B and C, but we want to, or not, sorry, A and C, but we want to hide them. So click on A, the bubble on A, and then click on the bubble for C. We need to get those things out of there. Because they're going to provide a little bit of clutter for us later on. We don't want that. Okay. All right, so the next thing we want to do is we want to take a circle, okay? Because what we're going to try to do is with an angle bisector, through the steps, there's 4 or 5 steps I'm going to give you here. What happens is that we create 2 objects that we know a lot about, okay? And the circles are going to allow us to create those 2 objects, okay? So the first thing we're going to do is we're going to go up to the circle tool right here. It says circle. And we'll click that because I think I've got one that's maybe differently highlighted than what you have. And we've got a lot of options there for circles. We want to go down to the one that says circle with center and radius. Circle with center and radius. And click on that. All right. And as you got a lot of options there, and you've never used this before. So if you're curious on what those other options were, or even what this option does, once I click on that option and then put my cursor over the tool, it says select the center point and then enter a radius. So we're going to select the center point, and it's going to then prompt us to type a radius in. So I'm going to click on B to be my center point, and then you see it prompts me to write radius. I want everybody to type in 5. Okay? Now, to be honest with you, it doesn't really matter what you plug in here, but just to keep everybody kind of on the same page, I think it's best to just do 5. Okay? Then hit OK. And it gives me a circle. Okay? Now, some of your screens, you're zoomed in, you might be zoomed away, zoomed out, whatever. My suggestion to you is we want to be able to see at least where the circle intersects the angle. Okay? So if you're like this, if you're zoomed in like that, that's okay. If you're zoomed in like that, you probably want to zoom out a little bit. Okay? If you're zoomed in like this, you can't even see the circle. You want to zoom out, right? Don't zoom out too far to where your circle looks like a point, right? Okay? So we want to be, kind of find that happy medium in there. Okay? Now, what we are interested in is where the circle intersects the rays and where it intersects the angle. Okay? So once you come up to your point tool, go down to the word intersect. Okay? And if I highlight intersect, it says select intersection or select 2 objects successively. So I can either go to where I think an intersection that I'm looking at right there that I'm interested in, and I can click there, or I think what's more useful and works a little bit better is to click the 2 objects that you want to find the intersection of. So I want to find the intersection of the circle and then the intersection of that ray. And it should put point D in there. Okay. I want to do it again because there's 2 intersections, right? There's an intersection of the circle with this ray down here. So I'm going to click on my intersection tool again, make sure that's highlighted. Okay, you see the kind of the blue highlight around there to tell you that that's the tool that's being used. And again, I can click on the ray and then the circle, but I could also do the same thing over here. My ray is ray G, and you see how it highlighted when I clicked it here, you see all highlighted over here. And then my circle is right here underneath what we call a conic, and if I click on that, it puts in point E. So somehow, using either one of those techniques, we want to find points D and E. Okay. When we're doing this, if you were doing this by hand, or you see on, obviously you're on the end of course exam, they're not going to give you a compass. They're not going to give you a straight edge on that thing. They're going to ask you, they're going to give you pictures. They're going to ask you to kind of walk yourself through their pictures and their steps. You're going to see something that looks like this because we don't really want, I guess I shouldn't say want, but we don't need the entire circle.
Our goal was just to find those two spots that the circle intersected the angle. So on the end of course exam, instead of seeing that picture there, you're only going to see that picture. Does that kind of make sense? Okay. You're only going to see the portions of the circles that provide intersections of other objects. Okay. GeoGebra, and I wish it had a tool for us to be able to do that. We could probably use the semicircle tool or something like that. That's kind of a pain in the butt to use. But we've got point D. Now, I don't really care. Like I said, I don't care about the circle. I just wanted the intersection points. So what is nice about GeoGebra is that I can actually come up to where it says conic here and click on the bubble, and it will hide the circle. It doesn't erase it, it just hides it. Okay, so go ahead and do that. Last class we see this word conic, and it kind of explained what conic means. What do you think the root word for conic is? Cone. Okay. So when you see something that's called a conic, and they're called conic sections, this is the math behind them. If we take two cones and we invert them on one another, we set them so that they're kind of reflections across one another in regards to their vertices. So we get these green cones. Basically, a conic, so we got four conic sections. A conic section is simply taking what we call a cross section. Okay, you guys know what cross sections are? If you take a loaf of bread and you cut it into slices, each slice is called a cross section, right? If you've ever had an MRI or a CAT scan done or anything like that, the pictures that they get from those things are cross sections of whatever they've scanned. Okay. When we talk about conic sections, they're cross sections of this set of cones. Okay, so I like to think about these cones. It's kind of a weird loaf of bread. Okay, and if I were to take a knife and cut a piece of bread out, there's several different ways I could do this. Okay, let's start with this app, which allows me to change the tool, and it allows me to change the angle of basically my knife. Okay, but if I take my cone and cut it that way, so I take my blade of my knife and I angle it a little bit so it passes through one cone completely, what kind of cross section, what kind of piece of bread would you get over here? What would you call that? Maybe if we change it a little bit more, yeah, you get what we call in like layman's terms an oval, but mathematically we call that an ellipse. Okay, but oval's fine right now. We also have some other things that we could do. We could change the angle of our blade and change it to where. Keep choosing the wrong tool. Change the blade so it looks. Let's see here. Sure, I can't see my alpha and beta, what those numbers are. Beta, there we go. All right, so if I do it this way, okay, so basically what happens is I take my blade and make sure my blade is perpendicular, or sorry, not parallel to a side of my cone. What does the cross section here look like? What have you talked about in Algebra 1? Towards the end of Algebra 1 last year, those are called what? Parabolas. Okay. Another option that we get, which you haven't talked about yet, is that thing. So we see over here, we cross both cones. That's called a hyperbola. Okay. And then the last one is when our cross section, when our blade of our knife cuts through that loaf of bread, and our blade is parallel to the base of the cone. What is that shape? A circle. Okay. So we get those four different objects that could be created from cones. That's actually a big portion of Algebra 2 that you guys go through. You go through an entire chapter. It takes quite a bit of time to get through talking about conic sections. So that's what that word means for us. Okay. Would you guys agree that the length from B to D and the length from B to E are the same? Yeah, because if I put the conic back in, you don't have to do this, but if I put that back in, weren't they radii of the same circle? And the two radii of the same circle have to be congruent. So what I want you guys to do real quick is just go up to your segment tool, click on it, and then click on B, and then to D, and then B to E. Now yours is probably going to be black, so I'll make mine black, because I don't really care the colors right now. But what that does for us is it, down on the bottom left-hand side in the algebra pane, you can see that H is 5, with H with B to D, and I is 5, with B to E, right? Those are congruent segments. So what I want to do is add some notation into our picture that reminds us that those two segments were congruent. So I want you to click on H, so left click on H over here in the pane, and then hold your control key down and click on I. So it should highlight both those things over there in the left-hand column. You're going to right-click then on those highlighted objects. Takes me to, should say selection. I'm going to go down to object properties. Okay. You guys probably, when this window comes up, it's probably on basic. Okay. I want you to go to the tab that says style. There's a lot of different things you can change here, but I want to change the decoration. I want to go to decoration. This is where I can show visually that segments that I have created are congruent or they're parallel. So I want to click on the first congruency thing that has the 1 hash mark in it.
Can we use the arrow?
No, because the arrow, I mean, you could use the arrow, but the arrow says that they're going to be parallel, and that's not what we want. So that's just a visual reminder. If I was doing this by hand, if I had a compass and straight edge in front of me and I was doing this by hand, it'd be really quick and easy to say if those are congruent by putting hash marks with my pencil in, right? That's the process that we have to go through with GeoGebra to do that. Okay. The next thing I want to do is go to point D and make a circle around point D. And I don't care how big it is. Okay, but I want to make it bigger than, either equal to or bigger than the circle that I just created. So let's actually make, let's make it 7. Okay? So I'm going to click on my circle tool, and I remember I wanted the second one here, circle with a center and radius. I'm going to click on D. Okay, remembering the last size I made was 5, so let's make this one 7. And hit OK. And it should give me that circle there, right? Okay. Now I want to go to E and draw the exact same circle around E. Okay, so I should be able, I still got my circle tool selected. Go down to E, click E. It's going to prompt me for a radius. Click 7, hit OK. Okay. Those two circles, and I'm going to color one of them so I can talk about it a little bit easier. I'm going to click on my arrow tool, and then I'm just going to come over here to the D one, click it, and I've highlighted it, and then I can just change the color to whatever I want. Okay, so I got that red one. And if you want to do that, you can. You don't have to, but I have that red circle. Does that red circle have the same radius as the black? So those two circles are congruent. That's the only thing we ever have to look at for circles to be congruent, is that their radiuses are the same. Okay? Do those two circles intersect? Yes. How many times? Twice. Okay? What we're looking for is the intersection that is on the inside of the angle. We don't really care about the intersection from the outside of the angle. We're only interested in one on the inside. Okay? So we want this intersection point over here. All right, so what I want to do is click on my intersect tool again, which is in that second drop-down window. Go down to intersect. And I'm going to click on the two circles. I'm going to click on the red circle, and then I'm going to click on the black circle. And it should show me all the different places they intersect. And here you see it shows F on the interior of the angle and G on the exterior of the angle. I don't really care about G, but it's fine to have it. Okay.
Is that doable?
All right. Now, go up to your segment tool. Click my segment tool, and then choose a color. I don't care what color you want to choose. I'm going to go. You see where your graphics here, where it says the word graphics?
Yeah.
You have it? Click on your, because you got your arrow. Click on segment. Now go down to the segment. Now it all came up. Okay, so I've got my segment. I'm just going to click on some of you have the word graphics here, some don't. Some just have this bar. But I want to change the color. And what I want to do is I want to go from point D to point F. Okay? And that's the radius of the red circle, isn't it? Okay, which is a length of 7, correct? That's what we chose. I want to then go from E to F, right? And E to F, what length is that? Is that the radius of the black circle? Is that 7? So what's that tell me about my two blue segments up there? They're what formula? They're congruent. Okay? So what I'm going to do is I'm going to come down to the two segments J and K. Those are my blue segments. I'm going to left click on them. I want to then, or not left, yeah, left click on that one. Hold my control key down. Left click on that one. I'm going to right click and go to Object Properties. Go to Lines, Decoration. And I'm going to click the second option here that has the 2 marks in it. And then close out of it. Okay? Does that make sense? Okay. Now, in the event of doing the actual construction of an angle bisector, I don't really need those 2 blue segments. Okay? But I wanted to put them in there to show you why we know for certain that we've created an angle bisector here. Come over to your conic sections, to your circles, and get rid of them. Okay, just go up to View, go to Output, and you're going to want to just grab that toolbar, and you should be able to kind of slide it over here and it should highlight it. What's that button do? All right, so when we do this construction, like I said, we don't necessarily 100% need these blue lines. Okay. When we did the construction, let me actually hide the lines real quick. We came up with the intersection of those 2 circles, right? And the intersection of those 2 circles provide me with point F. And if I've got point B and I've got point F, is that enough points to create a line? Yeah, so let's take our line segment tool here, go down to ray, and you could use a ray, you could use a line, you could use a segment, doesn't matter. I want to use a ray. I'm going to click on B and then click on F. What does it look like that ray has done to my original angle? Your original angle, my original angle. What's it look like it did? Cut it in half. Looks like it bisected it, right? Okay. Well, if I put back in those colored segments that we had forced in earlier, okay, and then I maybe, now you don't have to do this, but I just want to use a segment here. Let's get to that. Do you have a triangle up top?
Yes.
You have a triangle bottom?
Yep.
Visually, we've shown that we have two segments up top compared to 2 segments on the bottom, right? Well, what about that red segment?
That's
Congruent to itself, right? That's a reflexive property, right? So what do you know about those 2 triangles? They're congruent, okay? So we just used a series of circles to create 2 triangles that force 2 triangles to be congruent, right? if those two triangles are congruent, then what does that tell you? And they're congruent by side, 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 right? What does that tell you if I take my angle tool about that angle there and that angle there? They're the same. Okay? And you guys can use that angle tool. We'll get better at using that throughout the next couple weeks, but that green angle for me and that blue angle are now congruent. And that tells us then, yeah, these two over here are congruent, yes, and these two up here are congruent, yes. But in the event of what we were trying to do, we have now shown that ray B to F is in fact an angle bisector. And what's nice about this, in GeoGebra, we're able to now show that we've done that for one angle. We should be able to do that for an infinite number of angles, because what GeoGebra allows us to do is to move things around. If I go back to point A that we had on here and point C, those were the points that kind of defined my angle in the first place, right? If I start moving those, does that maintain that angle bisector? It allows me to now bisect any angle that I'd ever want to come across. Okay? Where if I was doing this by hand with paper, if I wanted to bisect an obtuse angle, I have to do that one obtuse angle in front of me. And then if somebody said, okay, now bisect an acute angle, I have to take that acute angle and now bisect that one acute angle. And every angle that I want to come across, I'd have to do those steps on it individually. But with GeoGebra, I can see, I can change it. I can make it, we call it dynamic. Change, move around, okay? If you can't change it, move things around, it's called static. Does that make sense? Everybody all right with that? I will, if you're messing around with this and you're struggling with getting what I have over here, I will post this GeoGebra applet on my website so you guys can access it, download it, whatever you want to do with it. But that provides us how to bisect an angle. I now want to talk about a feature about that angle bisecting. Okay, so once we've bisected the angle, we want to go back. I'm just going to kind of clean things up here. I'm going to get rid of AC. I'm going to get rid of, all the additional things in here that I used initially to get my angle bisector. Okay, but just hiding that stuff, right? So this is still an angle bisector. And I'm going to color it. I'm going to make it blue. All right, so my blue ray here is an angle bisector. The theorem I want to get at today is if I take a point that is on that angle bisector, and it doesn't matter what point you want. So click your point tool, and then just click somewhere in your XY plane. Okay, should create point H. I'm then going to click on the point tool again and go down to attach, detach. Okay, so I'll click that. And what the attach, detach does, it says click a point and then click another object. So I'm going to click the ray. And what that has done is now it's attached H to the ray, but it allows me to slide it and move it around. That make sense? Okay. Now my question to you is, if I'm standing on H, no matter where H is, as long as it's on the angle bisector, and I ask you to walk to, let's say, we color one of these rays. Let's say we want to walk to this bottom ray. So walk to the red ray from H. How many different ways could you do that? If I start at H and I want to walk to this red ray, could I walk from H to I? Is that a distance from that point to that ray? Okay. Could I walk from, let's say, to there? Is that walking to that red ray? Is that walking to the red ray? Is that walking to the red ray? How many different ways could I walk to that red ray? A lot, right? What's a better word for a lot? In this case, it'd be infinite, right? Okay. But of all those infinite ways that I can walk from H to that red ray, now look at the values down here. This one right here, this 10.94, is the length of that dotted line. Right there is kind of, I can't go beyond that, okay? Because B is kind of the corner that I can't get past, okay? So 13.95 is as large as I can go in that direction, okay? But as I start working this way, what happens to that 13.95? It starts to do what? Goes down, okay? Keep watching that number. What's it start eventually doing? Going back up. So if it starts going down and then eventually moves back up, it has reached somewhere a lowest point, hasn't it? A lowest value, a minimum value. And that's what we refer to as the distance from a point to a line. If I ask you, walk from H to the red ray, that is an understood walk, the shortest distance from H to the red ray. Okay? And that shortest distance is always found by looking at that angle right there. Okay? We want that angle. That angle changes as that distance changes, right? But when that distance is the shortest, what do you think that angle is going to be? Think about it right now, that distance at 9.99, right? Okay, look at my angle. It's 90.6, correct? If I move to the left, that angle starts getting bigger, and what happens to that? Oh, I'm looking at the wrong distance. Okay, so I'm looking at 90.6, and that distance of that dotted line is 9.09, right? As I go to the left, 9.09, that number keeps increasing, right? Okay? If I go back to 90 or as close to 90.6 as I can get. Okay? 9.09, now I go this way, and that angle starts getting smaller, right? But now as that angle gets smaller, what happens to that line gets bigger. So what is the angle measurement here in which that line transitions from being or becomes the smallest? What does that angle have to be, Cameron?
90.
It has to be 90. Okay? So when we want to find the distance from a point to a line, the shortest distance is an understood statement. Okay? But the way we find that shortest distance is we use perpendicular lines. Okay? So I want to walk through real quick how we would use GeoGebra to do this. Now, you guys are going to run out of time here, so I want to get you to lunch, but just kind of follow along. Don't do this on your own right now. But GeoGebra has the ability to say, I'm going to take this perpendicular tool, go to perpendicular line, and I click on H, and then I can click on the line that I want to be perpendicular to. So it automatically fits in that perpendicular line. And what's nice about that is, as I change the red line, you see how it changes the perpendicular line to it, right? It always forces it to be perpendicular. Okay? But when we do this, try to understand and make a connection about what we're doing. I don't really care about the whole line. I only care about from H to there. Okay, so I'm only really worried about that dotted distance. So let me get rid of the line. Is that doable? Okay, and we can guarantee ourselves. We can click on H and then I and then B, and it does give me a 90-degree angle. Okay, so that tells me when that's 90 degrees, that red dotted line is 8.7, and 8.7 is the smallest distance that you could travel from H to that red ray. Okay, now I want to do the same thing from H to the black ray. So I'll do that real quick here. Okay, so I get that, and I can check the angle again. Now I messed it up, but it's 270. So if that's 270, what's this inside angle got to be? 90. Okay, so we do know it's a 90-degree angle. what kind of triangles have I just created?
They are congruent, but on a way to figuring out that they are congruent, they have 90-degree angles in them. They got to be
Right triangles, right? Okay. Do we know, okay, going back to one of our circles, well, I guess it's not, sorry, it's not one of our circles because I didn't know where I put H. But do you know that this angle here is congruent to that angle there? Okay. If I ask GeoGebra to find out that length right there, is that congruent to itself? Okay. Is this leg congruent to that leg? Okay. So those two triangles are congruent. They're right triangles. You've shown a hypotenuse congruent to a hypotenuse and a leg congruent to a leg, right? So they're congruent by hypotenuse leg, correct? So if they're congruent by hypotenuse leg, what does that tell you about the red dotted lines? They are congruent by CPCTC. Okay, so what's that mean to us? That means no matter where H is, okay, if I'm standing at H and I want to walk to the sides of my angle, okay, the distance that I would walk would be the same. Okay, so any point, but here's the theorem that we learned from this: any point on an angle bisector is equidistant from the sides of the angle. Okay, we'll talk a little bit about an application maybe of this tomorrow. But that's the main theorem that should be able to provide you information on how to get through the rest of that homework and math itself. All right. So remember that's due tomorrow. Finish that up, and you guys go lunch.